Hello everyone, welcome to our channel Code with Sunny, and in this video I am going to talk about the very first problem of May Easy 2021 of Hacker Earth. Okay, and the problem name is T-Rex and their pairs. Okay, so before proceeding further into this problem, I just want to remind to my viewers that if you haven't subscribed to my channel yet, I will ask them to subscribe that and press the bell icon, since we are going to publish the editorials and the video explanations of various contests held on the various platforms, and also the competitive programming topics that would help you to boost your performance in CP. Okay, so let's discuss this problem now. We have been given an array of length n, and we have to count the number of pairs I comma j where I and j satisfy this relation, and this condition is going to be hold, that is aj minus ai must be equal to I square plus j square, where I and j should be like I and j both should be greater than or equal to 1 and less than equal to n, and I should be strictly less than j. Okay, and n is going to vary up to 10 power 5, that is number of elements of the array can go at most 10 power 5, and the array values are like 10 power 12. Okay, so let's together find it out what should be the best solution of this problem. You can easily see n is going to be like 10 power 5, so we cannot have a O of n squared solution. So this O of n squared solution will give us a TLE verdict. Okay, so I'm just trying to figure it out what should be the best solution, or you can think for O of n or O of n log n, since n is going to be like 10 power 5. Okay, so that's why also ai is going to be like 10 power 12, so you cannot take a integer data type, you must take a long data type to store integers. Okay, now coming back to this question, it is saying that we need to find I comma j distinct indices such that I should be like strictly less than j, and this condition must be hold, that is aj minus ai. Okay, so it should be like I square plus j square. Okay, we need to find total number of distinct pairs of I and j. Okay, so one approach is to like start traversing all the distinct I comma j. This should take off O of n square time. For every I, start j from I plus 1 up to the end, it would take off O of n square iterations, around n square iterations. This would give us a TLE. So let's try to find out what could be the O of n log n solution if there it is. Okay, so you can easily see I can just modify this relation. That is, I can just modify this relation. How I am going to modify this relation? Okay, so let's just rearrange the terms. It should be like, you can easily see aj minus j square must be equal to I square plus ai. Okay, so this is going to help us. How this is going to help us? So what I am going to do is I am going to just store aj minus j square for every j belongs to 1 to n. For every j belongs to 1 to n, I'm just storing the values of aj minus j square. Okay, if I will store the values of aj minus j square, and this should be equal to I square plus ai, okay, according to this condition, and we need to find the distinct pairs of I and j. So what I'm going to do is for every index of j starting from 1 to n, let's store all the entries in the frequency table map of this value ag minus j square in a map, and if it should be incremented by 1 for every j starting from, okay, I'm going to write j belongs to 1 to n. Okay, if I have already stored this in a map for every j belongs to 1 to n, now again I'm going to iterate from I equals to 1 to n and find this value I square plus ai. Okay, so let us say sum equals I square plus ai value. Okay, and I'm just trying to find out what are the distinct value, what are the number of values such that this I square plus ai must be equal to aj minus j square. So my answer should be incremented by answer plus equals map of number of elements whose value is exactly equal to I square plus AI. Okay, I square plus AI. Why I am going to do this? The reason is quite simple. You can easily see I have already stored aj minus j square in the map, and if I am just trying to find out I square plus ai value in the map, and if it exists, it means that there are some certain indices j that are present in my array already, such that this is going to yield a non-zero value, and my answer would be incremented by that value, that is the count of that value. Okay, so just I'm trying to find out what is the values of I square plus ai, which should be equal to aj minus j square, since this map is going to store the aj minus j square value for every indices j starting from 1 to n. I am just trying to increment my answer for the total number of indices j, such that the value aj minus j square must be equal to I square plus ai. That's why I am searching this I square plus ai value in this map, and if it exists, and it will return the frequency of that how many times this value is going to occur in my array. Okay, so this map will take off insertion and deletion will always be of log of n time. So at every time I am just inserting the value in the map, so my time complexity would be like n log of n, and my fetching time complexity, that is for every I from 1 to n, and I'm just fetching this value, would also take off log of n time. So overall time complexity would be like log of n, that is n log n. Okay, so this is going to pass all the test cases. Okay, if you're not going to understand this till now, no need to worry about. If you look over the code, it will be much more clearer to you. Okay, so let's try to understand the coding part also. I've already submitted the code. You can easily see passing all the test cases. It is very simple. Take n first, answer as initialize as 0, and there is a map that is going to store the values of array of I minus the I into I. Basically j also. You can also say start iterating from 1 to n and store the one of the entries. That is, you can either store the I into I minus array of I, or you are going to store array of I minus I into I. Okay, so you can easily see I am storing the value of array of I minus I into I in a map, and then again I am start iterating from 1 to n, and my sum would be like I into I plus array of I. Note that I am going to just use the different one. That is, if I am trying to store in a map is this value, then I would search for this value, because these two values must be equal and we need to find the distinct indices. Okay, so I have just stored array of I minus I square, so I am searching for I square plus array of I. Okay, my answer would be incremented by this value. Note that the pre-calculation would take off n log n time also, and fetching the answers and incrementing our answer would also take off n log n time. Okay, so this will pass all the test cases. So if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.